Hi everyone, and welcome to our video where we will be looking at some exam questions on the history of the atom. So our first exam question says that the diagram below shows another model of the atom. What is the name of this model? So as you can see, we have a ball of positive charge and we have negative electrons that are embedded within this positively charged ball. So the name of this model is just simply the plum pudding model. And that's all you have to say for 1 mark. Okay, moving on to the next question. Now, this is a common exam question. So it can get asked in a variety of different ways, but learning this mark scheme will just add to your list of points that you can say for a question that comes related to this topic. So it says the plum pudding model did not have a nucleus. Describe 3 other differences between the nuclear model and the of the atom and the plum pudding model. So the plum pudding model was a ball of positive charge and it had negative electrons embedded within it. That's what we just explained on the previous slide. Now, the nuclear model, the mass was concentrated in the center of the atom and the negative electrons were just embedded on the outside of the atom. So that's one difference. The plum pudding model was a ball of positive charge, whereas the nuclear model, the mass was concentrated in the center. The negative electrons surround the concentrated mass in the center. Okay, so if we have a look at the mock scheme, the points that you need to learn or you have to have an idea about in terms of the wording are these points. So the nuclear model is mostly empty space. So when we think of the nuclear model, the mass is concentrated in the center. That's a marking point, as you can see. And the rest of it, it's mainly empty space. Whereas when you have the plum pudding model, the whole of the plum pudding model is positively charged. Whereas in your nuclear model, the positive charge is only present within the nucleus. That's another difference. And in your nuclear model, the electrons on the nucleus, they are kept separate to each other. So when you're comparing the nuclear model of the atom versus the plum pudding model, these are the points that you need to learn. Okay, and this is a common exam question. So normally you get asked a question on the history of the atom on your Chem paper 1. So the nuclear model of the atom is mainly empty space. The positive charge is concentrated in the center, in the nucleus. The mass is also concentrated in the center, which you call the nucleus. And the electrons and the nucleus, they are kept separate, whereas in the plum pudding model, it's vice versa. It's a ball of positive charge with negative electrons embedded within it. The mass is evenly spread out. The positively charged aspect covers the whole atom, and the mass is concentrated evenly through the atom. It's not mainly empty space. Okay, so that's a common exam question. Please make sure that you make a flashcard of this model mock scheme answer. Moving on, it then says Niels Bohr adapted the nuclear model. Describe the change that Bohr made to the nuclear model. So when we had the original nuclear model, we had the nucleus in the center and we just had electrons around the nucleus, just scattered around the nucleus. Niels Bohr came in and he just adapted this nuclear model. He still had the nuclear model to his name, but the nuclear model was basically adapted to say that the electrons, they orbit the nucleus, they move around the nucleus, and they are at fixed positions around the nucleus. They are at fixed positions between the nucleus and the electron shells. So putting that into words, the 2 points that you need to learn for the nuclear model, how Niels Bohr adapted the nuclear model, is that he said the electrons, they orbit the nucleus, and they are held at specific distances from the nucleus. Those are the 2 alterations he made to the original nuclear model that was present. In the nuclear model, we just knew that the mass was concentrated in the center, that was the nucleus, and then the electrons, they were just scattered around the nucleus. But when Niels Bohr came in, he said that the electrons, they orbit the nucleus at specific distances. Okay, those are the 2 alterations he made to the nuclear model. Okay, moving on to the next question. It then says, Gallium was discovered 6 years after Mendeleev published his periodic table. Give 2 reasons why the discovery of gallium helped Mendeleev's periodic table to become accepted. Now, this is a topic which you need to learn. However, many people ignore this topic. They don't focus on it as much. And this comes under the development of the periodic table. So Mendeleev, what he did when he was publishing his periodic table is he left gaps within his periodic table because he knew that there were elements out there which hadn't yet been discovered. So what he did was he left gaps. He based the periodic table on properties, and he left gaps in the periodic table. And then as years passed by, new elements started to get discovered, and the properties of those elements, they matched the gaps that he left within his periodic table. And because they matched the gaps, that made the periodic table to become widely accepted, because his predictions of the properties of the elements which hadn't yet been discovered came true. So that's why people started to accept the fact that the periodic table has been ordered in the perfect way. So putting this into a mark scheme answer, what did Mendeleev do in terms of gallium? So he left gaps within his periodic table. When gallium was discovered 6 years later, gallium fitted the gap that he left within his periodic table. That's the first thing that you have to say. Okay, and the other thing that you have to say is that gallium's properties, they were predicted correctly, because the 2 things that he did was that he left the gap and he also predicted the properties that that specific element will have when it's discovered in the future. And when it was discovered, it fitted that gap perfectly, and its properties also matched to the ones that he predicted. So gallium fitted in the gap that he had left, and the properties were predicted correctly by Mendeleev. Okay, so those are the 2 marks that you need to state. Okay, and again, as I said, this is a very common exam question that many people tend to ignore and lose easy marks on. So please make sure that you've made a note of this mark scheme. Okay, so moving on, it says give the correct reason why Mendeleev reversed the order of some pairs of elements. So when he was developing his periodic table, a lot was going through his minds. Okay, a lot of combinations failed, and some of the elements that he placed within his periodic table, he had to switch them around again and again. You need to state a correct reason why he had to do that. And the reason why is because, remember, the periodic table is in groups and it's in periods. So remember, the groups, they have similar chemical properties. Okay, for example, group 1, they all have 1 electron in their outer energy level. Okay, so the reason why he had to switch around some pairs of elements is so that they matched the properties of the elements that were in its group. Okay, so for example, you might have to swap around a group 1 and a group 2 element, so the properties of that element will match the rest of the properties of the elements that are in group 1. So that's why he had to reverse the order of some pairs of elements that he originally placed in its periodic table. Okay, and final question now. This is a 3 marker, again on the development on the periodic table. It says Mendeleev left spaces marked with an asterisk. He left these spaces because he thought missing elements belonged there. Why did Mendeleev's periodic table become more widely accepted than previous versions? Again, this is a build-up from the question that we looked at previously, but that question was worth 2 marks. This one's worth 3 marks. So there's an additional point that they're looking for in this question. So remember, Mendeleev, he left gaps. He predicted the properties of the elements that are meant to go in that gap, and when the element was discovered, the element matched the properties that he predicted. Because his predictions were coming right, that's why it became more widely accepted than all the previous versions of the periodic table that have come about. So again, putting this into words, it says Mendeleev had predicted the properties of the missing elements. That's what we said. The elements were discovered, and then the properties which Mendeleev predicted matched the properties of the element which had been discovered. That's where your 3 marks are coming from. Okay, and ideally those are the 3 points that you need to note down for an exam question and in your flashcards that you can learn. Okay, and that's it for this video. Thank you for watching it. I wish you the best of luck with your GCSEs, and I'll see you in the next video.